Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0138, indicates a problem with the secondary heated oxygen sensor, also known as the secondary HO2S or sensor 2 in the Honda CR-V 2023 model. This fault signals that the output voltage from the sensor is higher than what the Powertrain Control Module, PCM, considers normal. The secondary HO2S plays a crucial role in monitoring the exhaust emissions to ensure that the air-fuel mixture is optimal for engine performance and efficiency. It is located downstream of the catalytic converter, ensuring that the exhaust gases are being treated properly. An abnormal reading in this sensor prompts the PCM to store the specific DTC, alerting the driver that there could be emissions issues or inefficiencies in fuel usage. Addressing this DTC promptly is essential to maintain your vehicle's performance and to minimize environmental impact. The secondary heated oxygen sensor, HO2S, detects the amount of oxygen in the exhaust gases and helps in optimizing the air-fuel ratio sent to the engine. It is specifically key in emissions control systems, ensuring that the vehicle complies with environmental regulations. Located specifically after the catalytic converter, it monitors the effectiveness of emissions control performance. When the voltage output from this sensor exceeds the acceptable range, the PCM interprets this as an issue, which leads to the triggering of the DTC P0138. The PCM relies on this data to determine if the engine is running too rich or too lean, thus affecting vehicle performance and fuel economy. The abnormal high-voltage reading could potentially indicate wiring issues or a faulty sensor itself, requiring thorough inspection and testing. The primary reasons for the occurrence of DTC P0138 include a malfunctioning secondary HO2S, issues with the wiring in the sensor circuit, or problems within the PCM itself. A faulty secondary HO2S might produce erratic voltage outputs that either over-report or under-report oxygen levels in the exhaust, leading to incorrect air-fuel mixture calculations. Additionally, wiring problems such as shorts or breaks can also result in false readings, causing the PCM to flag this DTC. Lastly, although less common, a malfunction in the PCM could potentially misinterpret the sensor signals, ultimately leading to the triggering of the DTC. Each of these causes requires careful inspection to determine the root of the issue. When the DTC P0138 is present, several symptoms may arise in the vehicle, making it important to recognize these signs. Drivers may notice a drop in fuel economy due to the engine running inefficiently, leading to increased fuel consumption. Additionally, erratic or rough engine performance could manifest as poor acceleration and inconsistent engine behavior, making the driving experience less enjoyable. Most notably, the check engine light will illuminate, alerting the driver to a system fault which requires immediate attention. Ignoring these symptoms can lead to more serious engine performance issues and increased emissions, highlighting the importance of prompt diagnostics and repairs to rectify the underlying problems. The first step in troubleshooting DTC P0138 involves starting the engine and maintaining the engine speed at 3,000 revolutions per minute, RPM, without any load until the radiator fan activates. This step is crucial as it allows the engine to reach optimal operating conditions while enabling the sensor to provide accurate readings. Once the radiator fan comes on, the vehicle should be allowed to idle, which will give a clear indication of whether the secondary HO2S is functioning within its intended parameters. By observing the readings at this stage, technicians can gather initial data to determine if further inspection of the secondary HO2S or the corresponding electrical circuitry is warranted. In the second step of troubleshooting, a thorough inspection of the external circuit is necessary. This includes checking both the SO2 circuit and the ground circuit, designated as SO2-SG. Utilizing a multimeter, technicians can measure the resistance within these circuits to verify whether they are functioning correctly. Ideally, the resistance for both circuits should be less than 1 ohm. If abnormalities are detected, such as high resistance or open circuits, it may indicate that the wiring is damaged or improperly connected. This step is essential for ensuring that the signals from the secondary HO2S are accurately communicated to the PCM, which helps in diagnosing the DTC effectively. The third step involves a detailed inspection and evaluation of the Powertrain Control Module, PCM. To breach this step, the secondary HO2S connector must be disconnected to allow for testing of the unit output voltage. A jumper wire is used to connect terminals number 1 and number 2 of the secondary HO2S connector. The vehicle is then turned to the on position without starting the engine to check the HDS, or Honda Diagnostic System, for the value of HO2S S2. If the output voltage exceeds the threshold of 3.28 volts, it indicates a malfunction and implies that the issue potentially lies within the PCM itself. Substitute the component if determined necessary. The final troubleshooting step focuses on the secondary heated oxygen sensor itself. At this juncture, all preceding inspection items should have been validated as normal. If the diagnostics point towards the secondary HO2S as the root cause, the sensor will require replacement. Verifying that the sensor is positioned correctly and securely connected is essential for accurate emissions readings. It is important to confirm that it is not subject to external damage or contamination. By replacing a faulty secondary HO2S, the system can correctly monitor emissions and maintain engine efficiency. It is expected that once this replacement is completed, the vehicle will return to normal operation without triggering the DTC again. After all necessary repairs have been made based on the previous inspections, it is essential to verify that the repairs were successful. The technician will begin by clearing the Diagnostic Trouble Code DTC using the HDS. Following the clearance, the vehicle should be test-driven to allow the engine to run through various operating conditions, enabling the PCM to assess the performance of the new or repaired components. During this test drive, it is essential to monitor the vehicle to see if the check engine light reappears, indicating that the DTC may not have been resolved. Should the system perform without any issues during this verification process, it asserts that the repair was effectively executed. Preventive maintenance is key to avoiding the recurrence of DTC P0138. Regular inspections of the secondary heated oxygen sensor, HO2S, can help identify potential wear or damage before they escalate into larger issues. Additionally, examining the sensor wiring regularly to ensure that there are no frays, corrosion, or disconnections is vital for ensuring the integrity of the electrical circuit. Maintaining the overall emissions control systems, including timely service of components like the catalytic converter, enhances the vehicle's performance and compliance with environmental standards. By incorporating these preventive practices into a regular maintenance routine, vehicle owners can mitigate risks associated with emissions-related faults, prolong the life of their components, and uphold fuel efficiency. In conclusion, understanding DTC P0138 involves recognizing that it indicates a high voltage problem with the secondary heated oxygen sensor. This technical issue requires careful inspection of both the sensor and its electrical circuits. By following the systematic troubleshooting steps, including testing the PCM and the vehicle's wiring, technicians can effectively pinpoint the fault, whether it be with the sensor itself or the associated circuitry. Ensuring that all repairs are confirmed through a clear process is essential to restoring the vehicle's performance. Moreover, adopting preventive maintenance practices can significantly reduce the likelihood of reoccurrences, ultimately leading to better engine efficiency and compliance with emission standards. Please like and subscribe to the channel. See you next time.